Hello dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy Karad, once again welcome you all to this yet another session of the chapter Fats and Oils. In this video, we are going to discuss about the analytical constant of fat and oil, that is the Reichert Miessl value. Now in previous videos, we have discussed the various analytical constants like acid value, saponification value, acetyl value, iodine value, and in this video we are going to discuss about the Reichert Miessl value. Now if you are coming first time to this my YouTube channel, then you can watch my previous videos like determination of iodine value, acid value, saponification value, and if you like the content of this particular channel, then you can subscribe to get the more videos related to the pharmaceutical organic chemistry. Now let's begin with our today's session, that is Reichert Miessl value. Now before that, just starting with our this session, we will see what are the learning outcomes of this particular session. After this session, students will be able to explain analytical constant used for the determination of the oil or fat sample, that is the Reichert Miessl value, which is also commonly known as RM value. Now what is this RM value? RM value is defined as the number of milliliters of 0.1 normal potassium hydroxide, that is the KOH solution, required to neutralize the steam volatile acids. This is very important. What we are going to neutralize are the steam volatile acids obtained by the hydrolysis of fat or oil. Now you may wonder, if we are going to carry out the hydrolysis, if we are going to carry out the neutralization of the acids, then what is the difference between the acid value and this RM value? Because in acid value also we are going to carry out the neutralization of the acids. Now the difference between the acid value and RM value is that in case of acid value we are going to carry out the neutralization of free fatty acids, while in case of RM value we are going to carry out the neutralization of only volatile acids, and which are obtained by the steam hydrolysis of the fat or oil sample. Those which are only lower molecular weight acids are there, they are generally volatile in nature, which are consisting of less number of carbon atoms. These volatile acids are only measured by using the Reichert Miessl value, that is the RM value. So this is the definition of this particular RM value. So once again I will repeat, it is defined as the number of milliliters of 0.1 normal KOH. Now here another difference, that in case of acid value we are measuring the number of milligrams of KOH. Now here instead of number of milligrams of KOH we are going to measure the milliliters of KOH, which is required to neutralize the steam volatile acids obtained by the hydrolysis of fat or oil. Now for determining the RM value, a known weight of fat or oil is completely saponified with the alkali. Now we know the saponification means what? When the fat or oil sample is reacted with the excess amount of alkali. As we know, fats and oils are nothing but the triglycerides, which are known as the esters of glyceride. So when they are treated with the alkali, they will be hydrolyzed and they will be converted into the glycerol and the free fatty acids. Further, as we are going to use the excess amount of alkali, free fatty acids that are generated, these free fatty acids once again, as they are capable of reacting with the alkali, they will react with the alkali, and once again sodium or potassium salt of free fatty acids are generated. This process is known as the saponification. So for determining RM value, known weight of sample is saponified with the help of the alkali. Now to remove the excess alkali, the solution that is obtained after saponification with the alkali is acidified with sulfuric acid. Once we have neutralized the excess amount of alkali with the help of the sulfuric acid, then this solution is subjected to the steam distillation, and due to steam distillation, whatever the sodium salts or potassium salts are generated, they will undergo the hydrolysis, and due to which there will be formation of volatile acids are obtained, and this distillate that is obtained is treated with 0.1 normal alkali solution, that is the potassium hydroxide solution. In this way, determination of RM value is carried out. Now we will see what is the RM value. RM value is a measure of the volatile fatty acids that are present in the given fat or oil. Volatile fatty acids, say for example acetic acid, this is nothing but the volatile fatty acids. So then butyric acid. So whatever the low carbon or low molecular weight fatty acids are there, they are generally known as the volatile fatty acids. So this RM value is used to measure the content of these volatile fatty acids that are present in the given fat or oil. Now it is of special value in testing the purity of butter and the vegetable ghee, which contains the high proportion of glycerides of butyric acid and other steam volatile fatty acids. As I said, volatile fatty acids includes examples like butyric acid, propionic acid, acetic acids. So the proportion of these volatile fatty acids are more in the butter as well as the vegetable ghee. So for testing the purity of this butter and the vegetable ghee, this RM value is used. Also, it is used to check the adulteration of butter or ghee with the lower oils which are having the lower RM value. This number is also useful indicator of non-fat compounds that are present in the edible fats and is especially higher in the butter. So the butter is also adulterated with the non-fat compounds. So this RM value is of great significance to check whether butter is adulterated with the non-fat compounds or not. So these are various uses where we can use this particular RM value to check this particular adulteration, then proportion of volatile fatty acids that are present in the given fat or oil. Mainly it is used to check vegetable ghee as well as the butter. The value is named for the chemist who has developed is, the name of that chemist is Emil Reichert and Reichert Miessl. So these are the two independent scientists are there. They have developed this particular value, and by combining both the names, that is the Emil Reichert and the Reichert Miessl, this particular value is used. Now after completion of this, we will see what is the principle involved in the determination of the RM value. Now in this particular method, first milk fat is saponified. Here we are considering the example of milk fat, because you can take any example, butter, or you can say vegetable ghee, means which fat or oil sample you have to analyze, that can be taken. So now milk fat, or you can say sample, is saponified using glycerol alkali solution. So alkali is used to carry out the saponification of this particular fat or oil sample. Then it is diluted with water and acidified by the sulfuric acid to liberate the free acids. So what happens? When the saponification is carried out, there will be formation of the sodium or potassium salt of that particular free fatty acid will takes place. When we add the sulfuric acid, it will carry out the neutralization of the alkali that we have added, as well as sulfuric acid is a strong acid, it will carry out the replacement of the free fatty acids that are present along with the sodium salt, because these free fatty acids are very weak in nature. So as sulfuric acid is a strong, it can easily replace, and which leads into the liberation of the free fatty acids. Thereafter, these liberated fatty acids are steam distilled in the glass apparatus under specified conditions, and steam volatile fatty acids are collected. As we know, in definition already we have said that Reichert Miessl value is used to check the volatile fatty acids that are obtained by the steam distillation. So due to the steam distillation, whatever the volatile fatty acids are there, they will be vaporized, and these vaporized free fatty acids are again collected as a distillate, and this distillate is used to carry out the titration with the 0.1 normal QH. Now the cooled condensate or distillate, you can say, of steam of volatile fatty acids is filtrated for separation of water solution and water insoluble fatty acids. The water soluble fatty acids which pass through the filter paper are estimated by titration with the alkali, that is the 0.1 normal potassium hydroxide, to obtain the RM value. As we know, like acid value, here the type of principle is same, where we are going to use the acid base titration of the titration, where the acids that are the volatile acids that are present or that are obtained after the steam distillation of our fat or oil sample, these volatile fatty acids, they are acting as acids, and they will be directly titrated with our alkali, where there will be neutralization reaction takes place, there will be formation of the salt will takes place, and at the end of titration, with the help of the phenolphthalein as indicator, we are going to determine the end point, because phenolphthalein in acidic condition will show the different color, and in basic condition it will show the pink color. So with the help of this, we can carry out the determination of the Reichert Miessl value. Now, after completion of the principle, just we will check what is the significance of this Reichert Miessl value. It is important index for quality of the milk. So to check the quality of the milk, this is the one of the important parameter that is used for the checking the quality of the milk. This is the useful indicator of non-fat compounds that are present in the edible fats. Generally, edible fats that are present, they are adulterated or they are mixed with the non-fat compounds. So this RM value will give the idea about the concentration of non-fat compounds that are present in the edible fats, because RM value of these edible fats is specific, it is present in this specific range, and if we determine this RM value and if they are not within these limits, then we can say they may be adulterated with the non-fat compounds. Also, RM value is a measure of the volatile water soluble acid constituents that are present in the fat. So this is about the RM value, where in detail we have seen what is the definition, how we are going to determine the RM value. Also we have seen the principle involved in the RM value as well as the significance in the determination of RM value. Now here this is the exercise for you. You have to go to this particular website, then use the passcode that is provided on your group, and you have to answer the questions that are given for this particular website. Thank you. If you have any queries related to the pharmaceutical organic chemistry, you can contact me on this particular email ID shahavishalv99@gmail.com. And if you like the content of this my channel, then please like my videos, share with your friends, and subscribe to my YouTube channel to get more videos related to the pharmaceutical organic chemistry. Stay tuned for other videos. Thank you.